In this video, I'm going to be going over the basic trigonometric identities. So let's start by talking about what this word identity means. So in math, an identity, it's an equation that always holds true no matter what value the variables take on. So a simple mathematical identity would be something like this. Okay, x plus y is equal to y plus x. No matter what value I give x and what value I give y, this will always be true. So a trig identity is an identity that has a trig function in it. We've already actually seen a few different types of trig identities. We just didn't call them trig identities. So the first type of trig identity are the fundamental identities. So the first one, we can say tangent of theta, where theta is an angle, is equal to sine of theta divided by cosine of theta. Okay, we saw something like this when we were talking about the unit circle. How we said tangent of theta is equal to y over x, sine of theta was equal to y, cosine of theta was equal to x. So if we say tangent of theta is equal to y over x, well, y is equal to sine of theta, x is equal to cosine of theta. So we can say that tangent theta is equal to sine theta over cosine theta. We also saw that cosecant of theta, let me number these, cosecant of theta is the reciprocal of sine. So that is a fundamental identity. Similarly, secant of theta is equal to 1 over cosine of theta. And then fourth one, we could say cotangent of theta is equal to, well, cotangent is the reciprocal of tangent, so we're just going to take the reciprocal of this, cosine theta over sine of theta. Okay, so I think we've either alluded to these, I don't know if we explicitly called each of these identities beforehand, but these hold true. And so let's just talk about this first one. Tangent of theta is equal to sine theta over cosine theta. No matter what angle we put in here for theta in each of these positions, the left side will always be equal to the right side. And that idea holds true for all of these identities. We also already saw the cofunction identities. So we said that sine of theta is equal to cosine of 90 degrees minus theta, right? And similarly, we saw that cosine of theta is equal to sine of 90 degrees minus theta, okay? We saw, so these two cofunction identities kind of go together. So we also saw two more pairs of these, okay? And here are the other two pairs. And remember, we can also use pi over 2 in place of the 90 degrees here. Okay, so those are the cofunction identities. So we've seen all of these before. We're going to look at two more identities here. Next batch are the even and odd identities. If we recall the definition of an even function, so a function is even if f of x is equal to f of negative x, and a function is odd if negative of the function is equal to f of negative x. So this was covered in college algebra, and two ways, or a way that we can think about each of these graphically. An even function is symmetrical about the y-axis. Okay, so something like the quadratic function, that's going to be an even function. It's symmetrical about the y-axis. A function is odd if it's symmetrical about the origin And an example of that, so we saw that y is equal to x squared here. Y is equal to x cubed would be an odd function. Okay, so that's symmetrical about the line y is equal to x. All right, so some of the trig functions are even, some of the trig functions are odd. So let's see, what should I start with? How about the even functions? So the even trig functions are cosine of theta and secant of theta. Okay, so cosine, if we say cosine of theta, that is equal to cosine of negative theta, just like what we saw up here. Similarly, secant of theta is equal to secant of negative theta. All right, and then the odd functions are the remaining four trig functions. So sine of theta, cosecant of theta, and then tangent and cotangent. Okay, so in each of these cases, we would say sine of negative theta is equal to negative of sine theta. So this is what we see up here. And then the same holds true for each of the remaining three trig functions. So for the even and odd trig functions, for right now, it's a good idea to try and remember these. These will make more sense, though, once we start to graph each of these trig functions. And the last trig identity we're going to go through is called the Pythagorean identity. This is probably the most used of the identities and the one that we'll come across most frequently. So that identity is sine squared of theta plus cosine squared of theta is equal to 1. So let's talk about where this comes from. So suppose we draw a right triangle in the coordinate plane, and the hypotenuse has a value of 1. So this triangle is on, it's kind of like the hypotenuse is, or this point right here is landing on the unit circle. So that point would be x comma y. All right, so we can use the Pythagorean theorem for this right triangle to represent this relationship as x squared plus y squared is equal to r squared. Because r is equal to 1, we could say x squared plus y squared is equal to 1. Well, previously when we talked about the unit circle, we said that x is equal to cosine of theta and y is equal to sine of theta. So squaring this on both sides, we get x squared. So I can substitute x squared for cosine squared of theta. And then similarly square both sides here, and we get y squared is equal to sine squared of theta. So sine squared of theta, 1 squared, it's just 1. So that's where this is coming from. Now, a little side note here. Sine of theta squared, we can write that as sine squared of theta. That means the same thing. But really what that means is to find sine of theta, and then whatever that value is, we will square it. All right, so this is the first and most common of the Pythagorean identities. Now, let's suppose we go through and divide each of these terms by sine squared. So sine squared of theta plus, sine squared theta divided by sine squared theta plus cosine squared theta divided by sine squared theta is equal to 1 over sine squared of theta. Okay, so this first term, sine squared divided by sine squared, is going to be 1, plus cosine divided by sine, well, that is the reciprocal of tangent, so that's going to be cotangent. And and then 1 over sine squared. Well, the reciprocal of sine is cosecant, so it's cosecant squared. So this is the second version of the Pythagorean identity. And now, instead of dividing everything by sine squared, let's take the original identity and divide this time by cosine squared. And doing so, that first term will be sine squared over cosine squared, which is tangent. So tangent squared of theta plus cosine squared over cosine squared is 1. And then the reciprocal of cosine squared is secant squared of theta. So we get 3 versions of the Pythagorean identity. My recommendation would be just memorize the first one, and then remember, okay, if we divide through by sine squared, we get this version, and then if we divide the first identity through by cosine squared, we get this version. All right, so let's go through a couple of examples of how we can use these identities. For the first one, it says, given that sine of 45 degrees is equal to root 2 over 2, and cosine of 45 degrees is root 2 over 2, find tangent of 45. Well, we know that tangent of some angle is equal to the sine of that angle divided by the cosine of that angle. So sine of the angle here, which is 45 degrees, is root 2 over 2. Then cosine of 45 degrees is also root 2 over 2, so that is just equal to 1. Now, we could have just seen this on the unit circle, tangent of 45. 45 degrees is one of the values on the unit circle, so if we think about the unit circle, we should know that tangent of 45 is equal to 1, but this is just illustrating another way to find this value, and an instance where it's useful to know this identity right here. This next one says, given that sine of 5 pi over 6 is 1/2 and cosine of 5 pi over 6 is negative root 3 over 2, find secant of 5 pi over 6. Well, secant of an angle is equal to 1 over cosine of that angle. So in other words, secant and cosecant are reciprocals of each other. So if we know what cosine is equal to, we just take the reciprocal of that, and that'll get us secant. So secant of 5 pi over 6 is equal to 1 over negative root 3 over 2, which is the same thing as negative 2 divided by root 3. So negative 2 divided by root 3. If we want to rationalize that, we'll end up with negative 2 root 3 over 3. That'll do it. Again, 5 pi over 6 is a value on the unit circle, but remembering this identity is going to make this easy. All right, in this example, it wants us to simplify the expression secant of alpha divided by tangent of alpha. So when we say simplify, what we want to do is remove fractions, if possible. Sometimes we'll be able to, sometimes we won't be able to. So remove fractions. We want to have just a single trig function. So in this expression, we have secant of alpha and tangent of alpha. So we have 2 different trig functions. So we want a single trig function. And then lastly, we want a single term. So here we have just one term. Okay, a term is just a mathematical expression separated by a plus or a minus sign. So we only have one expression here. So all of these are if possible. And again, sometimes all of these will be possible, sometimes they won't be. All right, so secant of alpha divided by tangent of alpha. A useful strategy for something like this is to convert everything into sine and cosine. So secant of alpha is equal to 1 over cosine of alpha. Tangent of alpha is equal to sine of alpha divided by cosine of alpha. All right, so when we are dividing fractions, we can multiply by the reciprocal. Okay, and we can cross cancel the cosine alphas. So we end up with 1 over sine alpha. So we're pretty good. We have a single trig function now. We have a single term, but we still have a fraction. So sine of alpha is the sine and cosecant are reciprocals of each other. So I can rewrite 1 over sine of alpha as cosecant of alpha. All right, another simplification example. And again, this expression is tangent of beta times cosine of beta. And again, I want to try rewriting everything in terms of sine and cosine. So tangent of beta is sine of beta over cosine of beta. And then multiply that by cosine of beta. So I can write that over 1, cross cancel. We end up with sine of beta as the simplification. So that one's pretty straightforward. All right, and then let's look at 2 more simplification problems here. Why don't you pause and see if you can figure these out on your own? And then when you're ready, press play and see what you're able to, see if what your work was matches what I have. I apologize because in my notes that I had written down, I think I made a mistake with this example, so I don't think we can actually simplify that one much more. So I apologize if you've spent some time trying to simplify that one, but go ahead and try the second one. And if you do that, cosecant of theta is the reciprocal of sine of theta. Cotangent of theta is cosine theta divided by sine of theta. These denominators will cancel. We'll end up with 1 over cosine of theta, which is the reciprocal of secant theta. And that'll do it.